Grace and peace to you, and welcome back to my channel. This is Donald Siami, author of Hidden Mathematical Genius Within Revealed. Today's lesson is on trigonometry that involves right-angled triangles. So let's discuss this trigonometry. Okay, so we know that the word trig is coming from the word triangle. So trigonometry is just the science of triangles. Now we are looking at right-angled triangles. Right-angled triangles. So a right-angled triangle is just a triangle with a 90 degrees, with one angle equal to 90 degrees. So it is written in this form. So this is an example of a right-angled triangle. So we have a 90 degrees this side. Okay. So what we should remember is that the side which is opposite to 90 degrees is called hypotenuse. Hypotenuse. And the other two sides are called adjacent sides. Now these adjacent sides, one of them should be an opposite side with regards to an angle. Let's say we have an angle theta this side. So if this is the angle theta, it means this adjacent side will be opposite, and the other one will be adjacent. Now, according to right-angled triangles, we have three trig ratios which we need to apply to calculate either angles or sides. Okay, so the trig ratios are sine, cosine, and tangent. So if you want to find the ratio for sine, according to this angle theta, we'll say sine of theta is equal to opposite over hypotenuse. Then cos theta is equal to adjacent over hypotenuse. Then tangent of theta, that is tan theta, is equal to opposite over adjacent. So these are the trig ratios which we will be using with regards to right-angled triangles. And the easiest way to remember this is by an acronym called SOHCAHTOA. So use SOHCAHTOA to remember these trig ratios. S is for sine, O is for opposite, H is for hypotenuse, C is for cosine, A adjacent, H hypotenuse, T tan, O opposite, A adjacent. So these are the trig ratios. Sine of theta is equal to opposite over hypotenuse. Cosine of theta is equal to adjacent over hypotenuse. Tan of theta is equal to opposite over adjacent. Okay, let us try to calculate or to answer the following questions. So we have the diagram. Then what is the question? Find the value of BC. Find the value of BC. That is the length BC. Okay, so we can see that here, this side BC has an angle which is opposite to it. So this BC will be opposite. And we have this side AB. So AB, according to the angle, will be adjacent. So we have adjacent side and we have opposite side. So when you have opposite and adjacent, which trig ratio should we use in order for us to calculate for BC? Yes, when we have opposite and adjacent, then we can use a tan. So say a tan of 37 degrees is equal to, so tan is equal to opposite over adjacent. So opposite is BC over adjacent is 8 centimeters. So for us to remain with BC, we are going to cross multiplying. So here we have a fraction. Even this side is supposed to be a fraction. So you say over 1. Then you cross multiplying. So you say 1 multiplied by BC, you get BC is equal to 8 centimeters multiplied by tan 37 degrees. So we have 8 times tan 37 degrees. So BC is equal to, so what is 8 multiplied by tan 37? So we are going to use a calculator. So we'll say 8 multiplied by tan is here, so tan 37. 8 multiplied by tan 37. So this is equal to, we have 6.028432401. Okay, so if the number is not exact and the degree of accuracy is not specified, round off to 3 significant figures. So 3 significant figures, we'll stop at, we have 1, 2, 3. We'll stop at 2. Then we look at the next digit. If it's 5 and above, you add a 1. So we can see that the next digit is 8, which is above 5. So you add the 1 to 2. So you get 3. So BC is equal to 6.03 centimeters. So that is the value for BC. Okay, we go to B. B calculate the value of AD. Calculate the value of AD. So AD is there. So what are we going to use to calculate this AD? Okay, and we can see that there we don't have an angle, because if you get this triangle here, a triangle ACD, we can see that there is no angle in that triangle. So what we can do, we can try to find this side AC. Then if you have two sides of a right angle triangle, then the other side can be calculated by using Pythagoras theorem. So let us try to calculate the side AC. So how are we going to find this side AC? Okay, so this AC with regards to the angle this side will be hypotenuse. So the AC will be hypotenuse. Then this side we have will be adjacent according to the angle 37. So when we have hypotenuse and adjacent, then we can use cosine. Yes. So we'll say cos of 37 degrees is equal to adjacent, which is 8 centimeters, over hypotenuse, which is AC. So we have cos 37 degrees is equal to 8 centimeters over AC. Okay, so here it's just a matter of cross multiplication. Okay, so you cross multiply. So you say this is over 1. Then you cross multiply, you say A multiplied by AC multiplied by cos 37. You get AC cos 37 degrees. 1 multiplied by 8 centimeters, you get 8 centimeters. Okay, now since we are solving for AC, we are going to divide through cos 37. So you say over cos 37, and this side over cos 37. Okay, so AC is equal to, so that is 8 divided by cos 37. Okay, so we have 8 divided by cos 37. Okay, so you get 10.0170852.7. Okay, again, the degree of accuracy is not specified, and the answer is not exact, so we round off to 3 significant figures. So 3 significant figures here, we'll stop at 1. Then the next digit is 7, which is 5 and above, so you add a 1, so you get 2. So AC is equal to 10.02 centimeters. Okay, so we have AC. Okay, so this is the triangle, a right angle triangle, that is ACD. So AC, we have 10.02. CD we have 24, and we are looking for AD. We can see that AD is an hypotenuse side, and according to Pythagoras theorem, if you want to solve for hypotenuse side, you say its hypotenuse, which is AD, you square it, equal to the sum of squares of adjacent sides. So it will be 10.02 squared plus 24 squared. Okay, so we have AD squared is equal to, so what is 10.02 squared plus 24 squared. Okay, so you get 676.4004. Okay, so now we are not solving for AD squared, but AD. So for us to remain with AD, we are going to square root both sides. So you square root both sides. So square root this side and square root the other side. So you say square root and squared, you cancel out. So you remain with AD is equal to, what is the square root for 676.4004? So you say square root answer equals, so that is 26.007698886. Okay, so you round off to 3 significant figures. So 3 significant figures, according to this number, will stop at 0, and the next digit there is 0. So you don't add anything, but you just get rid of the decimal places. So AD is equal to 26.0 centimeters. Okay, so that is the answer for AD. We go to C. So C, sine angle DAC. So here we are only finding the ratio. It's not the size of angle ADC, but just a ratio. And we know that sine ratio is equal to opposite over hypotenuse. Okay, so we want to solve for sine of angle DAC. Angle DAC. So angle DAC. So angle D AC. This is the angle. Okay, so sine is equal to opposite over hypotenuse. So according to this angle, opposite is which side? So opposite will be CD, which is 24 centimeters. So you have 24 centimeters over, then hypotenuse. Sine is equal to opposite over hypotenuse. So hypotenuse side, this is the right angle triangle. So the hypotenuse will be AD, and AD we calculated as 26. So it's 24 centimeters over 26 centimeters. So first you cancel out the units. So we have 24 over 26. So what is the highest common factor for 24 and 26? Yes, 2. 2 in 24, you get 12. And 2 in 26, you get 13. So sine of angle DAC is equal to 12 over 13. So this is how you perform calculations with regards to right-angled triangles. That is trigonometry involving right-angled triangles. Thank you so much for your time.